We have got two timing pulleys with a timing belt. We need to machine a plate that holds these at the right distance. Let's do a real quick CAD tutorial on how we can measure accurately that distance between the two and have it be versatile as well. Welcome to an NYC CNC Quickie. Okay, now yes, you could take the center location, and you can figure it out that way. But what I want to do today is use the outside dimension, because sometimes that either may be all you have or it's just the way to do it, and it's fun to know that you can sort of hack CAD or brute force it and get it to do what you want to do. It's really simple. Let's take a look at Solidworks. So here's our Solidworks model. I'm really excited for this tutorial. We're going to have a surprise device here, a motor here, and then the motor will have the smaller pulley on it. The larger pulley needs to go over here, and it needs to be the correct distance away so that that belt is tensioned. So what do? Well, we know the outside dimension, the outside edge here to the outside edge here is 3.95. Again, I know you could figure out the radius and then the center dimension, but let's do the outside. New sketch on this plane. Choose a line. Click on the outside of the circle and just click over here. Now, go ahead and dimension that line, 3.95. Now, what you can do is, let's see here, I remember whether I can get it to snap to or not without a, I think it's easier to put a dot point in there. There might be a trick to not have to do that. So now, hit the mouse cursor, click on the line, and click on that point, and click on coincident. And then you can see this relationship here keeps the edge of the line on the edge of the circle. That keeps it going through the center of the circle. So watch, as we drag that line, it's a 3.95 from the outside edge of the hole. Perfect, right? Now we happen to know that that's going to push us to the outside of that hole. So we know, for example, that that gear is 1.725 inches. So what we'll do is we'll sketch another point on this line, and then we'll dimension that. 1.725 divided by 2. And that gives us the center of that hole. And now what you can do is just sketch on here a 1.725 inch ring. We'll change all this to construction here, so that you can at least see where it would be. And then what we actually want to do is just machine a 1/4 inch shaft through there. So that's what we'll actually do, is the cut. And features extrude cut. Perfect. Now let's set the dimension of it so where we want it to. So let's say from there to there, we'll say 0.75, and I think that'll actually put it on center between those two. Yeah, exactly. So how easy is that, folks? Now if we take a look, again, you can delete these two dimensions, and you can drag this around, and anywhere you move it, that belt will have the correct tension. I think that's really cool. And again, the trick is the power in parametric CAD of using constraints on dimensions and constraints on geometry. The CAD files for this are on our Patreon website, link below. If you want to give like $1 a month, it supports the channel, and it's going to be a place where you can find all the CAD files for the videos and projects that we do, the CAM files. We're going to be doing a monthly live video session for the Patreon supporters. So if you've got more specific questions or you want help with a project or machining, please consider supporting the Patreon website. But either way, we appreciate it, folks. Take care. See you next Wednesday.